Welcome back to the course with the introduction to Capella. Uh, Now we're going to basically wrap up the logical architecture with the section called Share Logical Architecture. And just going here and share the screen. So this is similar to what we did with the system analysis. We're going to now work towards sharing the logical architecture with others. The process, the capabilities that we want is basically similar to what we've seen before. And the steps with doing this is very similar to what we did with the system analysis phase. We basically are now using all the content we created and basically presenting that to people so that we can basically bring them on board. And as you saw in the capabilities diagram, it could be marketing people that we're going to be showing this to. It could be design teams. But in this case, it's going to be more focused towards the design teams and sharing ideas and thoughts that the system architect may have regarding the product. Approaches to do this sharing. First, of course, the first and best one is to use Capella to help do that, and I'm going to do that here in a few minutes. I'll show you how we can do that. You can always clip and paste into your favorite tool and create a presentation. You also can use the export capability of Capella to export images into a folder, and then you basically use those images similar to the cutting and pasting approach. But one thing we're going to do right now is we're going to talk a little bit about when you're doing the sharing of the logical analysis. A couple of things that we may want to do is actually remember what the goal is. The goal of logical architecture is to come up with a high-level concept that delivers on the required system functions. That's the high-level goal. So you want to come up with a concept that will basically deliver the functionality that you needed from system analysis. More of a secondary goal is to lay the foundation for detailed design. One of the key things that's really important is there's things called constraints. There are constraints around the problem that will basically limit what your architectural choices are. And those constraints, sometimes they're called requirements, or sometimes requirements can be of the form of a constraint. They're really non-negotiable. They're just things that you have to basically do and deliver. And those constraints really limit you to what you can do as far as a design goes. So what you're going to see is I'm going to add some constraints, and I've already added some constraints to the logical architecture based on information that I knew from my initial conversations with the operator who wanted to have this in their park. So what I'm going to do is I'm going to basically walk through the steps below here, and we'll show what we can do with these constraints. And I'll show you some of the constraints that I have. So I'm going to exit this. Okay, so here's some constraints now that have been added to the logical architecture diagram. One is that we're not going to rely on the Wi-Fi for the telemetry system to be used because the facility doesn't have consistent Wi-Fi. And also, there's a very common approach. There's two common approaches to doing Wi-Fi. You may actually have one Wi-Fi set up for an entire park, or you may actually have them set up as different units that you have to log on separately in different locations. And so, in this particular park, there are multiple Wi-Fi systems all with the same name, but you basically have to log in separately to get to them and to log in. And that's because it just seems to work better. They know where the problem is if they have an issue. So that's kind of but you have to log in separately. And one of the things you would run into then is that the telemetry systems would have to be initialized for each of those Wi-Fi. The other one is power consumption. Wi-Fi is expensive power-wise. It tends to consume a lot of power. So we want to minimize consumption of power across the board. This is not a really hard requirement, but it is something that we want to consider. So I did put it as a constraint. You could have a number value on it if you wanted to, but in this case, I'm just kind of, it's not as hard as basically do not rely on Wi-Fi. The other one here is we want to have roughly a 2-mile range. It's important that we have a range that's pretty far because the facility can be that set up in the sense that it's a pretty decent sized facility. And so we need range that's longer. And again, Wi-Fi tends to be only the size of a football field or less. So 2-mile range is a big difference. So that really starts defining what the hardware is that we might want to use for this system. And then, there's other, and let me just show you how we go ahead about add these constraints. I'm going to add another constraint. I'm going to go over here and I'm going to put that constraint right here. and I'm going to put in a constraint. So I'm going to put in here, system needs to detect theft from the system. So kind of I need some way to be able to detect when the unit might be taken from the facility. I have this constraint put in to do that. And I'm basically just going to use this constraint element, what I'm going to constrain that on, and I'm going to actually put that then on this kind of it actually could be on the whole trail power unit. Which, no, that's not true. It could be, I'm just going to put it on the telemetry system, which of course will be attached to the unit. So it needs to be, so when this thing is moved, we want to be able to detect it. So that adds another constraint. Now, the interesting thing here is, and these constraints, if you think of them all together, it kind of points to the fact that I'm going to need a low power way of detecting the theft. So just always running GPS full time and detecting movement may not be the best way. We may want to be able to figure out some way of turning the system on, for instance, when it detects motion, and then once it turns on, it could get a GPS lock, and then once the GPS lock is in place, then you could detect when it's actually moving outside the facility. Okay. So now I'm going to go on to the next thing I'm going to show you. Now, the last thing you can do is you can start capturing in this some ideas that you may have on that. Because as the architect, you probably have a pretty you understand some of the technologies that might be available. It may be actually influencing your decisions. So what I'm going to do is I'm actually going to show some of those options that I have. One of the options I may have for something, let's say I want to go and add this GPS module. Well, here's an option for a GPS module. This is something from Adafruit that's available that we could use for GPS. So what I'm going to do is I'm just going to capture this information here. I'm going to just do a quick paste of the link to it. And I'm going to put that on this location. I'm going to put this on this object here. And I'm going to open up the Properties tab, go to Descriptions. And you notice here I've actually put in some ideas of what the telemetry system might be. So this was for telemetry. And now I might put in options for GPS. And so there's my GPS option. And there's no reason why I couldn't even add a picture of it. So if I go here, this guy here, I could have this. You can just grab a quick screenshot of it with your favorite screenshot capture tool. And I could actually stick a screenshot in here of it. Something like that. So I can get an idea of what I'm thinking about. Now, the other thing is I may want to have different options for telemetry. So this is what I have right now, but I might go off and find another telemetry option. For instance, one that can detect motion so that I can use that for the motion detection. But this is a very important feature of being able to capture some information like this. Again, you want to pass on to the design team, whoever's doing the design, as much information as possible. And if you're providing them the Capella model, they can now go in and look and see what you might be thinking about when you're doing this process. Another thing that we may want to talk about is the communications module, what I'm going to use to communication. Again, we can't use Wi-Fi, so what might be used for that? There's some great options for doing communications. One of the ones that is very popular is LoRa. This is a low power radio option. This is an example of it right here, $19 in stock. I've used this before. It's a very inexpensive option to add radio communications. Of course, you would need two of them. You would need one on the telemetry system, but also would need to have one on the charge tracker. So you would need to have that kind of set up. So this is one of those. Anyway, this is some more ideas of what you can do to help annotate your design and before you're starting to send it off to somebody else to go work on. So we've put some options in here. So anyway, that kind of concludes this section. I hope you've enjoyed this class. Now we'll be going on to the physical architecture after that, which really gets into designing how we can deliver this logical architecture. Thank you.